All right, so now we're going to start some new content. So this will be brand new. All right. This is something we did not do at all last year. So you're really going to have to focus your brain and really be focused in on this and take some time to let yourself absorb this. Okay. All right. So we are going to be doing volume. Okay. So we've done area. So area is just the space between two curves. So now we're going to talk about volume, and we know volume is three-dimensional. So first of all, how are we getting volume to begin with? All right, so our outcome is I can find the volume of a solid formed by an area revolved around an axis. All right, so we're going to take an area and then we're going to rotate it around an axis, and it's going to create a three-dimensional object. And we're going to find the volume of that object. All right. And there are two different methods. The first one is the disk method. So this video is solely about the disk method. All right. So let's get into what this is. So we're going to take an area and rotate it around an axis. So I wanted to get your brain thinking about what this means. So I've got some pictures I want us to draw so you can get a visual to know what's going on. All right, so what would we get if we rotated each of these given areas around the horizontal axis that it is drawn upon? So if we take this rectangle and rotate it around this axis, then that rectangle is going to rotate down here, and we're going to be spinning in a circle, right? This thing is going to be spinning in a circle. So you're going to end up getting a little cylinder. I can't spell. All right, so you're going to get a little cylinder. So sideways cylinder, it's got circles on the sides. So this looks like a can of tuna or something, all right, or a cat food or something. All right, and then this one, if we were to spin that shape around this horizontal axis right here, if you spin that shape would come on this side, and it would be spinning in a circle. So this would make a circle here, and this would make a circle. All of these would make circles going around. So this would look kind of like a jug or something, all right? So this would be like a round jug, all right, with a round bottom, and you pour something in the top of it, okay? All right, this one, if we were to rotate this shape around this horizontal axis, that shape would come on this side, and it would spin like this. So this would be circular. All right, so it would look kind of like an egg. All right, so that's what we're going to do. We're going to take a two-dimensional shape, we're going to spin it around an axis, and we're going to calculate the volume of that particular shape. All right, now you can do horizontal or you can spin vertically. So let's just do a few practice ones spinning vertically around. So if we were to take this rectangle and spin it around this vertical axis, the rectangle would come on this side, and it would be spinning around in a circle. So that would look like a tall cylinder, all right? This one, same thing. If we spin it around this axis, this shape is going to come on this side, like that, but it's going to spin and be spinning in a circle. So even here, there's going to be a circle here as it spins around. All right, so that might look like a big round ketchup bottle instead of more rectangular ketchup bottles, but a big round round circular ketchup bottle. All right, this one, if I spin this around this vertical axis, this shape is going to come on this side, and it's going to spin in a circle. So that's going to look like half a grapefruit or something like that, or half a watermelon or something. And then this one, if I spin this around this axis, this triangle is going to come on this side. Of course, this is spinning in a circle, so that's going to create a cone. So you take a triangle, spin it, makes a cone. Take a rectangle, spin it, makes a cylinder. Okay, and this shape, not quite a triangle. Makes kind of a little hemisphere type thing. It's almost a semicircle, almost a quarter circle. Spin it, makes a hemisphere. All right. So that's what we're going to be doing. Taking two-dimensional objects, spinning them around an axis, creates a volume. Now we got to figure out what the volume of that figure is. All right, of that solid. All right, so these are called solids of revolution. Revolution because it's spinning around in a circle. So a region in a plane is revolved around a line called the axis of revolution. All right, so we're taking, this is the one where I said it looks kind of like a circular ketchup bottle. I've taken this little shape here and spinning it around this axis so it spins around this way. All right, so we end up getting this kind of circular ketchup bottle type thing, or barbecue sauce or something. All right, and what you get, I must be hungry. All right, what you get is a solid, a three-dimensional solid, okay? Now, what we're going to do, the simplest thing you can spin is a rectangle. So the simplest thing you can spin is to take like a green rectangle and spin it around the axis. That's the simplest thing you can spin. And that creates what we call a disc, all right? So we're going to revolve a rectangle and it makes a disc. Now what we're going to think about in order to get the total volume of this entire shape, whatever you want to call this, ketchup bottle, whatever, you're going to divide it into a bunch of discs, all right? A bunch of these, all right? So this is going to be a whole bunch of these that are going to be split up, okay? So this would be a rectangle, spins around here like this, and you end up getting a whole bunch of discs. So think of slicing this into a bunch of these nickel quarter type things, okay? So it's a disc. So you're slicing this into a bunch of pieces. So what we're going to do is we're going to find the volume of each individual disc, okay, which is like a quarter, and we are going to sum up all those, okay? So that's what we're going to do. So we're finding the volume created by this. Let me draw this whole shape. This whole shape starts here and goes up like this and down, and this shape was spun around the axis and it created this like jug, okay? Now, we're going to find the volume of the jug, and the way we're going to do this is we're going to sum up all the individual discs, because the simplest thing to rotate around is a rectangle. And when you rotate a rectangle around, it makes a disc, all right, or a very skinny cylinder is what it is, okay? So we're basically going to chunk this whole thing up into a bunch of those. So we're basically going to slice it into a bunch of slices and figure out the volume of each one of those individual slices, and then we're going to add them up. So if you can imagine where we're going with this, okay, so don't let this bother you, this next slide here, all right? What we're doing here, the volume of a disc is the area of the circle, the area of the disc times the width. So to get the area of this blue disc, I need the area of the circle, and then I multiply that times the width or the height of this to get this volume of this little cylinder, all right, which is a disc, all right? So it's the area, which is of a circle, pi r squared, and then I multiply times the width to get the depth of this thing. And so there's the volume of just that one little blue piece. Now, what I want to do is I want to find the volume of the entire solid starting from here, A, and going over to here, B. I want the volume of the whole thing. So to do that, I chop that up into a bunch of blue discs. Instead of just having one, we got a bunch of them. So that's going to be a summation of a bunch of discs from 1 to however many n I choose that to be. All right, pi is right here, pi. R squared, now this is saying r x sub I because it depends on your radius where you are along this figure, because the radius of this one here is not the same as the radius of this one here. So the radius gets bigger as you go along, and then it stays consistent from this point over here. So this just represents some function that gives you the height of each of your radii. So pi, radius, whatever our radius is when we're on our counter, squared, and then W, the width, is this right here. The width is our change in x, our delta x right here. Now, you can kind of remember what we did when we did this a long time ago. when we found areas and things. What we're going to do is we're going to make the number of these little disks go to infinity, right? So this little expression right here, let the partition go to 0. That means we're going to let the width of even the largest slice that we cut, we're going to let that go to 0. So that means you're actually making the number of disks. So your number n of disks is going to go to infinity. Okay, so we're going to cut this thing into an infinite number of slices. So we're taking the limit of this thing and letting the number of slices go to infinity. And then that gives you this equation here. So in order to find the volume of this, we're going to cut this into an infinite number of slices and sum them all up. Now, when we did this before, we did an infinite number of rectangles and added up the rectangles to find the area, right, under the curve. Y'all remember doing that? When we found the area, we summed up the rectangles and we made the number of rectangles go to infinity. And that's how we got the integral from a to b to be the area between the curve and the x-axis. All right, and the same thing is happening here. We're letting the number of disks go to infinity. So the limit, this part here, the limit and the sigma, which I was trying to change my color, the limit and the sigma sign together, these two things together end up becoming the integral sign. So it's the integral from a to b of pi and then the radius, some function of the radius to give us whatever the radius of each one of these little shapes is, whatever the discs are, because they start off small and then they grow. The radius grows for each of the discs. So this function has to give me this equation right here, right, is what this is. Whatever this function equation is what would go here to give me the radius of each one of these little discs. So it's pi radius squared, and the width is so small because you cut this into an infinite number of pieces, your width ends up getting tiny, 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 so that becomes your dx because it's so infinitely small. All right, so this is the formula, which is not that bad. It's just an integral from a to b of pi, because we're always doing circles, and then some radius squared. So we just have to figure out what makes the radius. And that's all there is to this. I know that looks kind of weird at this point, and you're probably starting to freak out, but it's not that bad. All right. So let's start with some examples. I will do that in the next video because I don't want to make the video really, really long, so that in case you just want to come back and watch examples, you're not scooting through a whole bunch of content. So that was your content video, and now I'm going to do 5 examples in the next video.